Hello everyone, my name is Sergey Matov, I'm a software engineer in Mirantis, and on this video we will demonstrate how to set up simple performance tests to measure VM-to-VM packets per second rate on the OpenStack environment with Netronome Agilio solution based on OpenContrail SDN. For VM-to-VM scenario, we will use OpenStack cluster with 2 compute nodes. Each node has single interface for management and Netronome NFP-NIC for tenant traffic. For this deployment, one of 2 ports of each Netronome NIC are plugged into switch. In our scenario, VM-to-VM test will assume running single VM on each compute node. Each VM is having 2 virt.io NICs corresponding on 2 different virtual functions. Each of compute nodes is running Ubuntu 14.04 with 3.13 kernel. Every node based on multi-NUMA topology and have 12 cores per each NUMA. To perform high packet processing, compute node should fit several requirements. First of all, to fit SR IOV requirements, Intel MOMMU should be enabled and set to pass-through mode. Several host CPUs must be isolated to make Agilio virt.io relay daemon perform high-speed packet processing. Also, isolated CPUs will be used by Novo for vCPU pinning. Our deployment scenario requires huge pages to be set up. Both 2 MB and 1 GB huge pages are worked for us. In this scenario, we will use 1 GB huge pages. Agilio-based deployment for virt.io NICs requires virt.io relay daemon to be configured. For this scenario, virt.io relay will be pinned on CPU cores number 1 and number 2. To act as a generator and receiver, VM should use pinned vCPUs. For this, Nova should be configured in respect to isolated host CPU cores. To force VM, use huge pages, and CPU pinning appropriate configuration should be passed to Nova flavor. For this case, we will use flavor named Huge1G. When all configuration is done, we can set up VM-to-VM tests. We already got 2 VMs running on the cluster. Simplest way to measure packets per second rate is to run high-speed packet processor. We will use DPDK-based packet gen to set up appropriate packet flow for both sides. VMs are running Ubuntu 14.04 with 3.13 kernel. We will run packet gen and all additional setup using prepared configuration files. Following setup configured in respect to VM, MAC, and IP addresses. Maximum PPS can be achieved in traffic flow based on UDP 64 bytes packets. We will consider sum of all RX rates on both VMs as a result of the test. Let's start generation. We can see packets arriving. Now let's start generation on the backward side. We can see packets arriving on another VM. Let's collect average RX rate from both VMs. Average RX rate on first VM is 7.5 million packets per second. Average RX rate on second VM is 7.5 million packets per second. So we can conclude that average RX rate for all VMs is 15 million packets per second, which is corresponding to line rate on 10 gig interfaces. Let's take a look on CPU consumption. As we can see, virt.io LED consumes only 2 CPU cores. It should be noted that increasing packet size will reduce PPS rate but will not affect average bandwidth. Thank you for watching.